Hello students, from today we are going to learn the last chapter of the syllabus for the first sem examination, and that is D block and F block for the second sem. It's for the second sem, the last syllabus. Okay, and the name of the chapter is D block and F block elements. And there was one more topic inside this chapter, that is compounds of D block elements, where we are supposed to learn about the preparation properties of K2Cr2O7, potassium dichromate, and KMnO4, potassium permanganate. But this has been removed from the syllabus. I repeat again, under the chapter called D block, F block, we have to learn about these compounds of D block element, potassium dichromate, potassium permanganate preparation properties, but this has been removed from the syllabus. So therefore, in this chapter, you're going to learn about D block element and F block element only. No need to study about compounds of D block element. So first of all, we'll start with D block elements. After completing D block elements, we go to the F block elements. So from today, we'll be starting is D block elements. So students, always remember, in D block, F block, we're going to start with D block elements. And do remember, D block elements are those elements we say whose electronic configuration ends in D orbital. If the electronic configuration ends in p orbital, we call p block element. If the electronic configuration ends in s orbital, we call s block element. Similarly, okay, D block element configuration ends in d orbital. That's why we refer it as D block element. So these are those elements whose electronic configuration ends in d orbital. And do remember, the capacity of d orbital is 1 to 10 electrons. So how many electrons we can fit? From 1 to 10. Maximum is 10 in the d orbital. Now you need to remember the general electronic configuration of D block elements. EC means electronic configuration. The general electronic configuration of D block element is, you have to write like this: NS, N-1D. N stands for principal quantum number. This small n indicates principal quantum number, which actually denotes period in the periodic table, the small n meaning. So how to write? N-1, then write SD. Capacity of S is 2. So either it may be 1 out here or it may be 2. Maximum will be 2 electrons. D capacity is 10, so minimum will be 1 and maximum will be 10. So electrons. So this is the general configuration of D block elements, which you have to remember. NS 1 to 2, N-1, D 1 to 10. So this may be asked. So do remember the general electronic configuration of D block element, and N means principal quantum number, which denotes period in the periodic table. Now this D block element is of 3 types. There are 3 types of D block element, students. One is called first transition series, second transition series, and third transition series. So do remember, there are 3 types of D block element: first transition series, second transition series, and third transition series. Actually, there is fourth transition series also given in the book, but that is radioactive element, so we don't learn out here. So we just learn about the first 3, that is first transition, second transition, and third transition series are the 3 types of D block elements. Now let us see the members of these elements one by one. So students, first transition series members are here, second transition series members are here, and third transition series members are here, in which you have to be thorough with the first transition elements series. Second and third you don't have to study, but first transition series you have to learn. So let us see what are the members of first transition series. First of all, the members of first transition series are scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, and the last one is zinc. And you have to be thorough with the sequence. You have to remember the sequence of first transition series. Okay, so I repeat again: scandium, titanium, vanadium, chromium, manganese. Then you have iron, cobalt, nickel, copper, and zinc. Similarly, for second transition series, the members are deuterium, zirconium, novolium, molybdenum, technetium, ruthenium, rhodium, palladium, silver, and cadmium. Cd means cadmium. Similarly, for the third transition series, the members are lanthanum, hafnium, tantalum, tungsten, rhenium, osmium, and this is iridium, platinum, gold, and mercury. Ag means mercury. But out of these 3 series, first, second, and third transition series, we have to give more focus to the first transition series, and that also you have to remember the name in sequence. Okay, you have to remember the name in sequence. Not only that, you need to remember the atomic numbers also. So to remember, scandium is 21, titanium is 22, your vanadium is 23, chromium is 24, manganese is 25, iron is 26, cobalt is 27, nickel is 28, copper is 29, and zinc is 30. So not only the name in sequence, you have to remember the atomic number. Okay, and this is important for coordination compound chapter also. So remember the names of this element in sequence with atomic number 21 to 30. Whereas for these two, you don't have to remember the atomic numbers. For second transition series, no need to remember the atomic numbers. For third also, no need to remember the atomic number. But the first transition series, you need to remember. Now, with the help of this, we are going to make the configuration, students, of first transition, then second, then third. Now, see here how to make it. Do remember, whenever we make configuration out here, we go with noble gas configuration. So first write argon. Okay. Now argon means, do remember 18. Argon means 18 is gone. Okay. Argon means 18 is gone. And here we write 4s and 3d. So this much you remember. The first one you will remember for all of them. So just remember, scandium is argon, 4s, 3d. If you remember this much, students, you'll remember everything. Okay. So argon, 4s, 3d. Now argon atomic number is 18. If you put here 2 in S, it becomes 20, 1 in D, it becomes 21. So atomic number of scandium is 21. So it is 18 for argon, 19, 20, 21. So it's done. So this is for scandium, students. Okay, 18, 19, 20, 21. This is the configuration for scandium. Now when you may have to make it for titanium, you just have to do like this: argon 4s2. Now keep on filling up electron in D. D1 will become D2. So 18, 19, 20, 21, 22. So similarly, when you do for this, it will become argon 4s2, 3d3. Here will be 3. Similarly, if you do for chromium, it will become argon 4s2, 3d4. It will be 3d3, it will be 3d4. Then here it will be argon 4s2, 3d5. Now if you do for here, it will be 3d6. If you do out it will become 3d7. If you do out it will become 3d8. Now when you go to the copper, it will become argon 4s2, 3d9. And finally when you go to the zinc, it will become argon 4s2, 3d10. So if you see here, argon is common in all, 4s2 is common in all. But if you see D, I started filling from D1, D2, D3, D4, D5, D6, D7, D8, D9, D10. So this is how we make it for first transition series. Now for the second one, you can make a calculation. Without knowing the atomic number also, you can make the configuration. Okay, you just have to remember the sequence like this. After argon, what comes? Krypton. And after krypton, what comes? Xenon. Okay. After argon, krypton comes. After krypton, what comes? Xenon, students. Now, if it is 4s, you have to write here is 5s. And if it is 3d, here will be 4d. Just one above. 4s becomes 5s and 3d becomes 4d. Similarly here, if it is 5s, this will become 6s. And if it is 4d, it will become 5d. So 4, 3, 5, 4, 6, 5. It's just increasing by 1. Now the electron how to fill up. You'll say write on the same power. Power 2, power 1, power 2, power 1. So this will be the configuration for deuterium, though you don't know the atomic number, but we made the configuration for each students. Now how to make it for this? It will be same, but here will be 42. For this it will be same, it will be 43. So that means for this one it will become krypton 5s2, 4d4. Now when you do for this, it will become krypton 5s2, 4d5. Okay. Now if you go on in the same sequence, it will be 46. Everything will be same. 47. Everything will be same. 48. It will be 8 out here. Now when you make it for silver, it will be argon. Sorry, krypton 5s2, 4d 9. And finally, when you do for cadmium, it will be krypton 5s2, 4d10. So see here, students, without knowing the atomic numbers, we are making the configuration with the help of 3D. So you all understood till here? Now similarly, we'll make it for this one. So now here it will be same like this. Here will be xenon. and here will be 6s2 5d2, d1 became d2. If you do out here, it will be d3. If you do out here, it will be d4. So xenon 6s2 5d4. When you do for this, it will become 5d5, it will become 5d6, it will become 5d7, this will become 5d8. Now when you go for this, it will become xenon 6s2 5d9, and finally when you do for mercury, it will be xenon 6s2 5d10. So you understood the pattern how to make. So if you know for scandium, you can make it for the all rest which is below it. Similarly, if you know for scandium, you can make it for deuterium, whereby you know for all of them. And if you know for deuterium, you can make it for lanthanum, and the same thing will go for all of them. Now, one thing you have to remember out here is this one, which is the lower number here, 3. Less than 3 is 2, but 2f does not exist because f starts from 4. So you will know f orbital will come. Here the least number is 4. Less than 4 is what? 3. 3f does not exist because f starts from 4f. Here least is 5. Less than 5 is 4 and 4f exists. So therefore you will write here 4f 14 because the capacity of f orbital is 14. So here will be 4f 14 because the capacity of f orbital is 14. Here will be 4f 14 because capacity of f orbital is 14. So here also 4f 14 will come. Here also 4f 14 will come. And this is how the configuration completes. Now students, if you see out here in the first transition series, the electronic configuration is ending in 3D, whereas in second transition series the electronic configuration is ending in 4D, whereas in third transition series the electronic configuration is ending in 5D. So since in first transition series electronic configuration is ending in 3D, therefore it is also known by the name 3D series. Okay, and here if you see the electronic configuration is ending in 4D, therefore it is also known by the name 4D series. 4D series. Similarly, here if you see the electronic configuration ending in 5D, so instead of saying third transition series, you can say 5D series also. So do remember from here today that first transition series is also called 3D series because configuration ends in 3D. Second transition is called 4D series because configuration ends in 4D. And your third transition series is referred as 5D series because the configuration ends in 5D. Now students, if you see in these two number, this is n minus 1, n. N indicates period in the periodic table, so which is the highest number here? 4. So it indicates period. That means first transition series 3D series belongs to fourth period in the periodic table. They belong to fourth period in the periodic table, which is a higher number 5. So that means 4D series belongs to fifth period in the periodic table. Similarly, here the highest is 6. So 5D series belongs to the sixth period in the periodic table. It's very easy to remember, one higher. 3 belongs to fourth period, 4 belongs to fifth period, 5 belongs to sixth period. So do remember in which period they belong in the periodic table. So do remember first transition series is called 3D series, second is called 4D, third is called 5D series. 3D series belongs to fourth period, 4D belongs to the fifth period in the periodic table, and 5D belongs to the sixth period. Okay, so there's another name. Hope so you all understood till here. So therefore students, first transition series can be written as 3D series from now on, and it belongs to fourth period. Second transition series is called 4D series, and it belongs to the fifth period. And your third transition series is called 5D series, and it belongs to the sixth period in the periodic table. So students, in this configuration I made two configuration wrong. Okay, I made the configuration of two elements wrong in all the series. Now let us see who all are those. So here chromium and copper configuration, I have made it wrong. Here for molybdenum and silver, I have made the configuration wrong, and here I made for tungsten and gold configuration wrong. Because you have learned in class 11, d orbital fulfilled means there should be 10 electrons in the d, and half filled means it should have 5, and half filled and fulfilled orbitals are referred as stable orbital. So here you can see here 4s is 2, 3d is 4, but if I give one electron of s to the d, then you can see what happens. 4s also becomes half filled, 3d also becomes half filled and stable. So therefore this is the correct structure, atomic electronic configuration of chromium. Similarly here also in molybdenum, if we give one electron of s to the d, then both becomes half filled and stable. So this is the correct configuration for molybdenum. Similarly for tungsten, if we give one electron of s to the d, now both becomes half filled and stable. So therefore this is the correct configuration for chromium, molybdenum and tungsten. Similarly, if you see at the bottom this one, if you give one electron of s to the d, then s becomes half filled, d becomes full filled and it becomes stable. So this is the correct configuration for copper. Here also if you give one electron of s to the d, then s becomes half filled 1 and d becomes full filled. So this is the correct configuration for silver. Here also similarly if you give one electron of s to the d, s becomes half filled and d becomes full filled. So this is the correct structure of gold at electronic configuration of gold. This is 3d10, 5d10. So do remember total 6 of them has exceptional electronic configuration: chromium, molybdenum, tungsten, copper, silver, gold. They have exceptional electronic configuration. So I mentioned here in the note, chromium, molybdenum, tungsten, copper, silver, gold have exceptional electronic configuration, and this is how you have to remember. I made here all half filled stable, and I have made here d orbital full filled and stable. So please do remember students, full filled and half filled orbital are stable, and this configuration which is exceptional may be asked in your board exam. So learn the configuration for this 6. And as I said earlier, give more priority, okay, give more priority to first transition series, 3D series, which belongs to 4th period. Remember the name along with the atomic numbers in sequence. For these two, it's not required. Now students, what we will see is what does transition element means. It's a very important topic, okay, transition element, and from here every year 2-3 question comes in your board exam. So these are those elements whose d orbital is incompletely filled with electrons. Though the capacity of d orbital is 10, but if d contains 1 to 9, 1, 2, 3, 4, even 5, 6, 7, 8, 9. So if the d orbital contains electron from 1 to 9, those are referred as incompletely filled, and those are referred as transition elements. So transition elements are those elements whose d orbital is incompletely filled with electrons, means from 1 to 9 but not 10. So do remember the definition of transition element. Now students, let us check here who all are the transition elements here. You can see in scandium there is 1, 2, 3, 5, 5, then here will be 6, 7, 8. But in the bottom two there are d orbital is completely filled. So these two are not transition elements. So here copper zinc is not transition. Similarly, in the second transition series, d orbital is incomplete filled, they all are transition, but the bottom two are again not transition because d orbital is completely filled, d10, d10. Similarly, in third transition series also, d orbital is incompletely filled, they all are transition elements, but the bottom two again are not transition elements because their d orbital is completely filled with electrons, that is d10. So if you see out here, the second note, what I have written here, copper and zinc, cadmium and silver, gold and mercury are not referred as transition elements. Why? As their d orbital is completely filled with electrons. D10, 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 D10. To be transition element, these should have 1 to 9, but not 10. But these bottom two elements, all of them has 10 electrons in d orbital, so they are not referred as transition element. So copper, zinc, cadmium, silver, gold and mercury are not referred as transition elements because their d orbital is completely filled with electrons, we say. So that means who are the transition elements here? Scandium till nickel is transition, deuterium till palladium is transition, and here lanthanum till platinum are transition elements, but the bottom two are not because their d orbital is completely filled with electrons. Students, you can take the screenshot to make the notes, okay. So students, from here you can see transition elements are those elements whose d orbital is completely filled with electron, may contain 1 to 9 but not 10. So in first transition series, 3D series, the transition elements is from scandium till nickel. In second transition series, 4D series, the transition elements are from deuterium till palladium. In the third or 5D series, the transition element is from lanthanum to platinum. These all are transition elements, students. Okay, remember the definition and example for it. Now there is one question out here. The question says all transition elements are D block, but all D block elements are not transition. All transition comes under D block, but all D block are not transition. So to explain this question, students, I'll go out here again. You can see here, transition elements are those elements whose d orbital is incompletely filled with electrons. But their configuration ends in d orbital only, isn't it? So they all are d block elements. But there are some d block elements whose d orbital is completely filled with electrons. So they are d block, but they are not transition. I repeat again, as I said, use scandium till nickel is transition. Why? Because their d orbital is incompletely filled with electrons. And if the d orbital is incompletely filled with electrons, we call them transition element, and their configuration ends in d orbital. So therefore, all transition element comes under d block. But there are some d block elements whose d orbital is completely filled with electrons. They are d block elements, but these two are not referred as transition. Not referred as transition. So do remember, all transitions comes under d block because their configuration ends in d orbital, whereas all d block elements are not transition because their d orbital may be completely filled with electrons. Now you can see the answer for this question. Transition elements are those elements whose d orbital is incompletely filled with electron, and since their configuration ends in d orbital, due to which they are referred as d block elements. But there are some d block elements, copper, zinc, just while ago I shown you, whose d orbitals are completely filled with electrons, due to which they are not referred as transition element. Hence, all transition comes under d block, but all d block does not come under transition. Hence, the given statement by the question is true, that all transitions are d block, but all d block are not transition elements. Here is one question which has come in the board exam. Can zinc be called a transition element? Justify your answer. So you have to remember the zinc atomic number is 30, so you make argon 4 as 3d. So this is 18 plus 2, 20 plus 10, 30. This is the configuration of zinc. And it is clearly seen that in zinc, d orbital is completely filled with electrons, due to which it is not transition element. Because to be transition element, d should contain 1 to 9, but not 10. So in zinc case, d orbital is completely filled, due to which it is not referred as transition element. It's a ISC question, so do remember it, students. Now, students, what we will see is the oxidation states of first transition series. First transition series means 3D series. The members are here. The oxidation state may be plus 1, plus 2, plus 3, plus 4, plus 5, plus 6, plus 8. They have many oxidation states, you can see, in which in first transition series the highest oxidation state is of manganese, and that is plus 7. Do remember, so in first transition series, who has maximum oxidation state? Manganese. And what is the value of that? Plus 7. Similarly, in the second transition series, now we are going to see, in second transition series, this is the oxidation state of second transition series, in which the maximum is of ruthenium, which is plus 8. Do remember, others no need to remember, just remember the maximum one. Similarly, in third transition series, the maximum is of osmium. OS means osmium, and the maximum oxidation state of it is plus 8. So I may ask you the question, which has the maximum oxidation state in third transition series? Answer, osmium, value plus 8. You can check others. Similarly, in second transition series is ruthenium, the value plus 8. Whereas in first transition series, the maximum is of manganese, that is plus 7. So students, you are going to remember this one, maximum oxidation state. First transition series, 3D series, who has the maximum oxidation state? Manganese, symbol Mn, and the value is plus 7. There are many like plus 2, plus 3, plus 4 also, but remember the maximum one. In second transition series, 4D series, it is of ruthenium, Ru, plus 8. And in the third, 5D series is osmium, Os, plus 8. But if I ask you in general, what is the maximum oxidation state of transition series? In this question, did I mention first, second, third transition series? No, I am just saying transition series. So that time it will be plus 8. But if I ask for first, it is plus 7. For second, it is plus 8. And for third is also plus 8. And who all have? You have to remember the names for MCQ questions. Hope so you all understood. So in this video, I explain you what is D block element, what is transition element, why all transition comes under D block, why D block does not come under, all D block does not come under transition. I have mentioned you how to go with the configuration, some reasoning questions, and oxidation states. Hope so you all are understanding till here. So in my next video, I'll discuss much more about D block elements. After completing that only, we go to the A block elements. Thank you very much, students.